Hello everyone, welcome to my channel. So today we are going to do blind 75 sheets, one of the question, and basically we have solved a lot of them, and this time we are going ahead with the trees. So I'll show you. So this is the sheet which we are solving. Here category wise and name of the question, problem link and their video solution. Everything is there. So you can see that arrays we have solved, binary few are left, dynamic programming few of them are left, graph left. These are the those questions which are premium question, but still because video is there, so you will be able to see that question, it's constrained everything in that video itself, so you don't need to worry to buy a Leetcode premium. And yeah, interval question I'll solve and upload. Two of them I have already uploaded, which are of premium question, and also in that itself I would have provided alternate links where you can see that question. It's not necessary that you need to have Leetcode premium. You can have some alternate links also, which I have provided in the video itself. And few linked list are left. Matrix, string I have covered all. You can see string is all completed. Tree, now tree we are going to complete. Few of them I have already completed and uploaded, and heaps are all done. So now in today's video we will be going ahead with this question, maximum depth of tree. So that I have already opened in this tab. So let us first read this question, then we'll check out the constraint, then we'll check that whatever possibilities could be there for this particular question, that yeah we means basically the intuition that what comes into your mind, that yeah we need to solve this like this or this. So for all that purpose we will be discussing all that in video, and then at the end whatever possible solution and whatever constraints would be there accordingly, time complexity and space complexity, we will be checking and checking if there are any optimized method for the same. So that all things we are going to do and go ahead with the same. So let us quickly start. So here first let us read this question. So given the root of a binary tree, return its maximum depth. If required we can increase the font also, so that only this much portion we are able to focus. So that's the thing. So now here, given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So here, as per the question, they require the maximum depth of the binary tree, and what they meant by depth is that a binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So what they meant by all this is that, so here 3 is the root node, right? So what would be the depth of this particular tree? That would be this one, level 1, level 2, level 3. Basically 3 would be the depth. But what the definition says is that longest path from the root node along, basically the longest path along the root node means including this root node and going till the end of that leaf node, which is at the end. Or you can say this also, because both of them are at the end, means the towards the depth of that particular tree. So that's why we can take both of these paths, but anyhow we just require the depth of this particular tree, means what could be the maximum depth. So in that context it doesn't matter whichever path you choose, but that should be the longest path. And the next one which is there, one, null and 2. So this is the tree which is there. So here you can see this is level 1 and this is level 2, right? So that's why here the output is 2, because the depth of this particular tree is 2. Now you can clearly see that there could be any possibility, means there could be several paths which are the longest paths basically, but the ultimate goal is that you are required with the depth of that particular tree, and getting the depth of that tree also we can either go ahead with DFS part or BFS part. But now just think, what would be more optimal? anyhow you can get solution with both of them. But if you go ahead with BFS part, right? Let me take out the whiteboard so that I can explain. 1 minute. Okay, so for the I like black one, that's it. So now the tree which is given to us, it is something like this: 1 2 3, then 4 or 5, and here let us say it is null, and here it is say 7, right? So we know that this is level 1, this is level 2, and this is level 3, right? That is for sure we know. And now we require the maximum depth. For getting the maximum depth, we know that if we go ahead and do a depth first search, we will be directly going towards the last of that leaf node, whatever would be the last node, we will be able to directly go to that particular node, or it could be 4 also, or it could be the 7 also, right? Means we, how DFS is being done, it will check for its left, it will check for its right, right? And then for the left it will check if there is something. Okay, there is nothing, right? If it, then it will be checking for its right, there is something, then it will go ahead and check for its left, and then it will check for its right, nothing, then it will start returning. That is how it will be able to get something from this particular node, and that it will return to the main parent, that is this particular root. And same goes with these paths which are there, these two paths, right? So this is how depth search will work. But for the breadth first, so here what it will do, it will first go into the breadth of that particular. So because of that, you can clearly see it will be storing all those nodes. Means first it will check for this, fine, it checked, then it will check for its left and then its right, it will store both of them, then it will check for its left, for its right, store both of them, then it will check for its left, its right, then store both of them. And after that, when it has reached, then it will be able to get that, yeah, this is the last one node which is there, and it is having this much level, that is the 3, and that will be returned. That is how it will go ahead. So because of that, this BFS, it will be like not that much optimized as compared to if we will be going ahead with DFS. Is when we are required to go into the depth of the tree, it's preferred to go ahead with DFS solution. And even here also, although internally stacks are used, but you can clearly see that not that much space is being used the way we are traversing in this particular tree when it is DFS manner. And here queue would be used if we are going, means anyhow queue would be used, and here stack would be used in that context when we are doing iterative DFS. But internally, if we see, if we do a recursive DFS, then internally stack would be used, else it won't be using any other extra space if we don't consider that internal stack. So in that context also, you can see that DFS is more optimal as compared to doing BFS on a particular tree for figuring out depth of that particular tree. Now this is like a base stuff. Now comes the part what question actually asks. The question is asking that we are required to return the maximum depth of that particular tree. Then how we will be doing? I told that while we will be doing DFS, then in that context it will be checking for its left, its right, right? And then for the first recursive call, that is for the left, it will go into the depth of that left. When it will return something from there, then it will check for its right. Like this, it will be able to do DFS on that particular tree. So in whole this thing, what we are required to do, we are just required to return the length, means basically the depth of this particular tree. So for that context, we require some integer value, and in our question we need to code this thing in such a manner so that we can return that integral value. and accordingly we will be required to do coding also. Now here we hadn't even checked the constraint, but for the DFS and BFS, both of them would be having time complexity order of n. In the worst case scenario of a skewed tree, is basically rather than a tree like this, if it becomes something like this, right? So here the number of nodes will indicate the level of the tree, and thus it will be order of n. That is the scenario. But if it is a balanced tree, then in that context it would be order of log n. But we always check for the time complexity when it comes in the consideration for worst case scenario. So that's why it is order of n here. Now here, fine. Now here constraints are that nodes are up to 10 per 4. So anyhow order of n solution will clearly work here. And here node value also we don't means here we are not much considerate about the nodes value because we don't need to do some or something like that. So that's why. And now let us go ahead and start coding for this. We are here going to go ahead with DFS solution, and how we can do that I'll let you know now. So now let us start with the coding of the same. So because now the thing is that we are required with the fact that that we need to basically code in such a manner so that we can get the depth, right? And also we are required to traverse that particular tree. So in that context we will be using one auxiliary function, and that auxiliary function will help us for determining the length which is required at the end. 1 minute. Because of my alignment code becomes so tough for me. Okay, so now let us go ahead with the function. Now what I am going to do is I'm going to write a function, and in that function basically we would be having int and the tree node itself as the return type, so that this tree node which is there, that anyhow we will be using inside this own function, but the answer which we require, that we require because of that integer part, right? Because we require that depth. So that's why here itself what exactly we will be requiring would be, we will be requiring to return the integral part of that function, that is depth function, which we will be calling, and in that we will be passing the root, right? So this would be calling part done. Now we just require the integer part, right? So that's why we'll just go ahead and return this. Now comes the part that we need to solve this particular function. So now for this particular function, what all we require, we need to do DFS, mean we need to go towards the left, towards the right, and we need to compare both of those lengths, that out of a particular length which one is the greater one. And also we need to handle the edge case, that if root equals to null, if the tree has reached the null or the tree itself is null, for all those scenarios also we need to handle. And for that first we'll write that edge case, if not node, right? Then in that context we will be returning, because we need to return pair, right? So at that point it would be 0 comma the value would be null. So this will return at that point only. Now comes the next part. That node part is handled. Now we require basically two distances comparing left and right. So for that person, d1 we are choosing for the left, and d2 will choose for the right. So for getting this, what we require is the function itself which is there, we will be passing node left, basically the left side of that, and d1 will be having the first part of that because it is a pair, and d2 will be having the same thing, depth, and node right. And again the first part. So now here just for comparing those distances we have taken two variables, and in this we will be having the integer value. Now comes the part, the major part of comparison. Don't get confused in the same, it's pretty much easy. I'll explain line by means word by word whatever is here. So now the curly braces is for the fact of pair because our return type is a pair, right? So for that we are using curly braces. Now first thing, because our main part was to compare the lengths and get the depth, right? So now we will be doing max of d1 comma d2, right, plus 1 for the root, plus 1 comma. Now the integer part is done. Now the second part of this particular pair which is there, now that we will be doing. So now we require the node itself, right? So that we are required to return. So that returning part will be also on the basis of depth, right? That if left side is bigger or right side is bigger, or it is at the root itself, right? So for that purpose now we need to do. So the if, so basically in this scenario I will be using ternary operator so that it could be in a single line. So that is what we are doing. So now, so for that purpose, now we will check that d1 equals to d2. If that is the scenario, and basically I will be using ternary operator, right? So that it could be done all in a single line. So if that is the scenario, then in that context, we are required to return the node itself. That will return. If that is not the case, then in that context we need to again compare. That comparison would be in between d1 and d2, that whosoever is greater. If d1 is greater, then in that context we will be returning node left, else we are required to return node right. So this would be the thing for our comparison. This is for the first part which is there. Now the other things which I am doing, d1 equals to d2. This is for the fact that the second part which is there. So in that second part, anyhow we will be required to return the node, means the tree node type, right? That is the tree node type. So for that purpose only we are checking if d1 is equals to d2 at that particular moment, we will be returning node, else we will be checking that who is greater, d1 or d2. If d1 is greater, we will return node left, else we will return node right. So this this pair which would be there, that is just for this particular function only, because we are calling it recursively. So that's why we would be required to return the thing which is the return type of this particular function itself. That's why we are required to return here like this. And a major thing which was there, the integer part, that we are checking here in this line itself, that out of both whatever would be maximum, that will be returned by adding 1 to the same, that is the initial root node which was there. Now at the end, let us run this particular question and let us check if there is any compilation issue or something. So both are green, that means it got accepted. And yeah, let us submit and check if it got passed on all test cases. Yeah, it got accepted. So if we analyze the time complexity, anyhow it should be order of n. Let us see. Yeah, it is order of n. And space complexity, we are not using any extra space, but internally the stack space which is there, that is order of n, that is also for sure. So this was all for this particular question. If you like this video, you can like, subscribe and share among your friends. So yeah, this was all, and yeah, make sure to follow this particular sheet so that it's good to go. Yep, fine.